Hello, friends, students, colleagues, and C++ learners. This is Dr. Satish Singhal, PhD, from Computer Information Technology Department at Rose State College in Midwest City, Oklahoma. Today I'm going to describe 4 things that are available to every C++ class, no matter whether it has any data member or any functions or not. But these 4 are always available: a default constructor, a destructor, and an assignment operator. And in default constructors there are 2. One is the normal constructor and one is the copy constructor. Okay, and there is a reason for that. If class does not have a data member that would dynamically assign a memory to that data member, then everything works okay. You may only work with the default constructor. Other 3, destructor, assignment operator, or copy constructor, you don't have to touch. So this is really preparing a background for that situation, that if we have pointed to data member in the class and inside the constructor memory allocation is done, then we need to know about all those 4 things: default constructor, copy constructor, destructor, and assignment operator in a lot of detail. Okay, so imagine that we have a class called foo, and notice it has nothing in it, but that doesn't really matter. It's still, these 4 will always be provided by C++. Okay, it doesn't matter if class has anything or not. If you put something in there, that's fine too. So you'll always get a default constructor, which is called as soon as declarations such as like foo f is done. When you do any declaration like this one, default constructor will be called. Just think of this way, that without a mechanism to construct by means of something called a constructor, it will not get constructed. Okay, it's as simple as that, really. Okay. Okay, let's talk about default destructor before I talk about 2 and 3. Well, when foo gets out of scope, it has to be destroyed. If it is not destroyed, you have a memory leak in your program. Program is holding on to some variable that should otherwise be destroyed. So example of that is as follows, that if I create foo in this block here, some block, it could be a while loop, if, whatever, doesn't really matter, and I create a foo f like this. So the default constructor was called here. Maybe there's more code after that. More code, doesn't really matter. But as soon as this matching right brace is crossed, in this location here, below this foo f should not exist. It should be gone. How is that done? Well, a destructor is called automatically. You don't have to do anything. A destructor will be there, provided by the C++, and this f will be destroyed here. Okay. And all this happens because with this declaration like this one in C++, objects are created on the stack, not on the heap. So an automatic construction and destruction mechanism has to be part of the programming language. Okay. So we described to you default constructor and default destructor behavior. Let's talk about the copy constructor. Copy constructors come into play when you pass a class object by value to a function, or when function returns a value of a class object. A function can do two of them together or separately. That doesn't really matter actually. Okay. So imagine that I have think of this like main, int main. So let's say I have a function called foo that does return a foo and just return same thing, but it also takes a foo object as an argument, and then it might have some code, might have more code, and then it returns f. Okay, so we are trying to tell you, show you how the copy constructor will be invoked automatically, how it works. So let's say over here I created foo and I create another foo f2, and then I call this function called just return same thing. So I can say f2 equal to just return same thing, and we pass it f. So understand, when this function call is made, a copy of this, because it's being passed by value, a copy of f has to be made. And let's call it f1 so you're not confused that this is same as that. Okay. So a copy of f has to be made, which will be copied into f1. So how is that copy made? Okay, how is that copy made? Don't forget, this is an object. This is not an integer that you can write it in binary, simply a number. Okay, so it has to have a different mechanism. So lo and behold, there is a mechanism which is called a copy constructor, which is built in every C++ class. So when this is called, a copy of f has to be made into f1, and to do that copying, a copy constructor is used, which is present in the C++ class. Whether its code is visible to you or not, doesn't really matter. Works behind the scene. Okay. Then let's say you're returning this one. Understand that before it can be copied into f2, the return value, this object will be destroyed, because as soon as you cross this curly brace, this is gone. So in return mechanism, a copy of this again has to be made and copied into this one. So copy constructor is called second time when you return a value from a function. If you return an object from a function, so copy constructor is called when you're passing by value and when you're returning by value. Both places copy constructor is called. And once again, it's hidden, it's given to you. Let's think of the third thing, that f equal to f2. So in this case, two objects are already constructed. We're just saying that, okay, copy member by member from f2 into f. If both objects are already constructed, then that is done by using a assignment operator. We should call it default overloaded assignment operator, because objects, you've learned that objects cannot be copied into each other unless assignment operator is available. We call it overloading because normal assignment really copies only the primitives like float, double, etc., int, etc. So we call it overloaded because it's specially provided actually. So these four things, a constructor, a copy constructor, a overloaded assignment operator, and default destructor, they are always provided. Okay. And same thing, once the execution of main finishes, then all these objects, this one, they have to be destroyed. So destructor will be called again. Okay, so this is the basic background. So you can say, well, that's well and good. Can we prove it? Well, sure we can. We'll write a class foo like this one, but we'll add code for each one for the default constructor, copy constructor, overloaded assignment operator, and destructor. And inside them, we'll not put any code other than putting the cout from each one. And you'll see that if we do these operations that we have done here, if default constructor is called here, then we should get the output statement from the default constructor. If copy constructor is called here, we should get that. And if assignment operator is called, we should get that. And once the execution finishes, objects have to be destroyed, we should get the destructor call. Okay, let's go to Xcode. And first I want to show you the syntax of all these things. Okay, so this is the class foo. Notice has no data member. This is the syntax for, at least in this case, default constructor. Since it has no data member, I'm not going to put anything there. But there is the output statement that from ctor means constructor. Ctor is the short form for constructor, so that you're not confused about it. You do remember it all the time. Ctor means constructor. And it's an industry-wide abbreviation. Learn it. Don't fight it. It's worldwide universal. Short form for constructor is ctor. So we're going to use that because everybody in the industry uses it. Okay. Well, the syntax of writing copy constructor is this. That, don't forget that constructor have to have the same name as class name. But it is taking an argument of f type which needs to be copied wherever the copy constructor is invoked, and then we have a output statement from inside that from copy ctor of foo and nothing else, because we are just trying to see how, in what situation these will be called. Assignment operator has to set the right hand side object equal to the left hand. Copies everything from right hand side object to the left hand side. So it takes an argument just like copy constructor does, but it has to return something. So this is the syntax for overloading the assignment operator, and there is a reason for putting const here. We won't go into that right now. It returns a foo type by reference. Doesn't have to be by reference, but this makes life a little bit easier. And then it's taking this f and it's returning it. Okay. And then if this is executed, we'll get this statement printed. Okay. And destructor is easy. Destructor is always coded with a tilde in the front. Destructor also has the same name as the constructor, but it has a tilde in the front. So let me repeat one more time. Constructors always have the same name as the class. Copy constructor will take an argument of the class type as it is here. Destructor also has the same name as the class, but it has a tilde in the front. And destructor takes no argument. Okay, don't make the mistake of putting arguments in your destructor. And then it's printing also that from destructor for foo. Okay. All right. So default constructor, copy constructor, assignment operator, and destructor. Now one more thing. Constructors, you can have more than one, default and explicit, but you can never have more than one of copy constructor, assignment operator, and destructor. Those would be one each only. Okay, don't let anybody tell you anything else. They are not, I mean, this is already overloaded, so you can't overload copy constructor. Okay, it's a constructor already, so can't overload that. Okay, so I'm going to go into main code here and let me comment out stuff that I don't want. Okay. Okay, I think there's a way to comment that out. Okay, I'll just comment with the hand. Okay, so in both these cases, I'm creating an object f1 and f2. Default constructor will be called. Here will be our output, and you will clearly see it. It's not a problem. So let's run it. And you can see we got these 4 statements here. If those are not clear to you, I'll copy and paste that over here. Well, actually, that won't increase the font too much. I think they're clear actually. So when F1 is created, we get the message that from ctor of foo, because the copy constructor, sorry, the regular constructor, default constructor has been called. So we get this message for the F1. And then F2 is created, and we get the second message that from ctor of foo. So once again, the regular default constructor is called. But interestingly enough, we get 2 more messages, destructor for foo and destructor for foo. That's because the rest of the code was copied out and function calls ends. So as I said, whatever gets constructed has to be destructed. Okay, so that you see 2 destructor calls corresponding to each other, and they happen in the reverse order. The one that gets constructed first gets destroyed last. So really these 2 go together, and this go together. Okay, we won't worry about that too much right now. Okay, so that's the construction and destruction. Okay, let's code in assignment. By now you know, if you have learned some C++, that assignment operator works for classes, structures, and unions. So if I make a statement like this, then from F1 to F2, a member-wise copy of all the data has to be done. Although this class has no data, but if you had data, it wouldn't really make any difference. So let's see what happens here. Here we are promising that assignment operator will be called. And lo and behold, exactly that's what happened. And these 2, as we said earlier, were from these 2 constructor calls. But this one gives me this message that from overloaded assignment operator for foo called. And that's this one. So obviously this was called when this was done. Okay. We can show this to you also through debugging process. Maybe I'll just do it just for this only. Let's see. And then we can run it. It will stop there. Okay, and if I step over, step into, so here I can step over. Now I do the step into. So if assignment operator is being called, I should jump to the code of there, that, and there you go. See, I jump to the assignment operator here. This F is going to have same value, same address as the one here. Okay, so you can see I'm executing the assignment operator, and now I can just step over. Okay, and we got this message from overloaded assignment operator. So you see that works. Okay, so the breakpoint is on. That's how assignment operator is used. Anytime you're setting one object using the assignment operator equal to the other, assignment operator is called. Let's see the behavior of copy constructor. It's not a magic. Copy constructors are used. I create a third object F3. Obviously a default constructor will be called here, and there is the output statement from main function before calling just return the same thing. So this is the same function that I showed you earlier. It's called just return the same thing. It takes an F by value, not by reference, and then if this is executed from inside a function just return the same thing, this message will be given, and then it's returning F. So let's see when we code this in, what happens. Okay. Okay. So we had already understood up to here we'll get the message from the assignment operator, and which is this one. So we get the CTOR of foo because I declared F3. So that comes from there. And then I get this message from the main function, that from main function before calling just return same thing, that. And then here I'm calling the function just return same thing, passing an argument F2. So notice then I get a call from copy constructor, because a copy of F2 have to be made inside F. So a copy constructor does that, and if you don't believe me, I can actually run it using the debugging process. So click here, and then we can click it. It's going to stop there, and we can step into just return the same thing. So notice it didn't go there. It actually went to the copy constructor first, see? Because it has to make a copy. So it jumps to copy constructor, and so it printed that one from copy constructor of foo. And then copy mechanism is finished. So came back here. Now it's going to the just return the same thing inside the function actually. And then it prints from the inside the function just return the same thing. And now it has to return this F. So it has to make a copy of F, copy of this F. So it jumps to the copy constructor again. Okay. To make that copy. So this statement gets printed from copy CTOR of foo. And then it comes back over here to do the return part of it, and then it is done. Okay. Okay, the way I do it here, overloaded assignment operator is called again, but yeah, it has to be, because it has to make a copy from one to the other, and if we keep doing it, it is complete, and now it's beginning to call the destructors. And you can see that code jumped to the destructor. Okay, so destructors are being executed for all the objects that were created. Okay, so we have a bunch of destructor calls. Easiest way to see destructor will be, I'm gonna do a little bit more coding in a second. I'll show that to you a little bit better in a second. But notice that, okay, let me run it one more time. Oh, okay, I'll delete that. Sorry about that. Delete breakpoint. Okay. Yeah. So that's how all of these are called in different situations. If you do a simple assignment, this will be called. If you pass by value, copy constructor is called. If you return a value, copy constructor is called. If you take the return value into another variable, then assignment operator will be called again, and destructor will be called nevertheless. So we have pretty much proven it by this output here. Okay, so let's see. Let me copy this output here, because I'm going to provide you a copy of this code in my blog with this video. Okay. All right. So I promised I was going to show you the destructor, and for that, let me just call it main1. I'm going to create another int, sorry, main here, and I'm just going to create another block. So here I call foo_f, and here cout last line of main before return /n. Okay. So let's run this one. Okay. So we step into, we'll call the constructor. There you go. And now it got constructed, so we got this message from ctor of foo. We keep doing step into. So we're done. So notice that when this brace ends, the foo has to be destroyed. At line 43, foo should not exist. So now it's jumping to the destructor. So we get the message destructor of foo. So destructor job is done. And now this execution will take place from the last line of main before return. Okay, that's how destructors work. So this mechanism of construction, copying, destruction, and assignment works beautifully as long as you do not have a pointer data member in the class for which memory is allocated inside the constructor. Does member-wise copy, everything works beautifully. Works pretty much the same I've shown. If you had class member, it'll just make copy of that as well. But the problem comes when we have a pointer as a data member. I will not discuss that in this video. I will discuss in the next video. In this video, the goal was that I just wanted you to understand mechanism of these four: the default constructor, copy constructor, overloaded assignment operator, and destructor. All four are provided. If you overload this one, that's the only one overloaded, you will get an explicit constructor, one or more. These three are standard, they cannot be overloaded. Okay. So rest, I will talk to you in the next video. Thanks for watching. This is Dr. Satish Singhal, PhD, saying goodbye for now. Thanks a lot.